So let's start today's question. Let's start today's session with a question from the arrays, because we have been discussing about arrays from the previous session, and now we'll continue the discussion on arrays. So this is the first question that will appear on the screen. First, I'll explain the question, and then you tell me different approaches. So if you see it here over here, so we have an array. So in array there are n elements. So you have to rotate this array once. So what's the meaning of rotation? So if you take an example over here, so this is 1, 2, 3, 4, 5. Okay, this is 1, 2, 3, 4, 5. So if I say rotate it once, so rotate it once means you will rotate the whole thing over here, and this 5 will appear here. Okay, and if I rotate it twice, it means this 4 will appear here. Okay, and here if you see example, I have given 1, 2, 3, 4, 5, and I have, I think, 5 rotations. So this is what array is after 5 rotations. And let's suppose we have an input like this. I've given different inputs, but I hope that you understood this. But here the question is that you only have to make one rotation. You don't have to make multiple rotations. The question is that you only have to make one rotation. If you have an array like this 1, 2, 3, 4, 5, and you have to rotate it once. Okay, so I'll just pause the recording, think about how to rotate this array, and tell me different approaches. There can be two types of rotation though. This is 1, 2, 3, 4, 5. One rotation can be, we can rotate it from here or from here. So you'll have to think about both the things. So the first rotation that I said is we can have a left rotation. So left rotation means, so I'll rotate this one over here. So it will be 2, 3, 4, 5, and 1 will be here. This is left rotation. Okay. And what is the right rotation? Right rotation is something like this. So you rotate it like this. So you'll bring 5 over here. 5, 1, 2, 3, and 4, something like this. So you saw the difference. This is called a left rotation. This is right rotation by 1. So you have an array like this, 1, 2, 3, 4, 5. And then you have to make this left. Let's stick to this. You have to make this rotation, left rotation. So what the approach Rian said is that we'll take a variable. So he said we'll take, let's suppose we're talking about the left rotation. So in the left rotation, that means we'll have to get this output. This is the output that we'll have to get. So what we'll do is we'll take this one, we'll store it in a variable. Let's call that variable, let's suppose we store this one over here. After that, what we'll do is we'll shift all the elements. We'll shift this 2 over here, we'll shift this 3 over here, we'll shift these elements, we'll shift this, and last space, this will be unoccupied, and there we'll put this. So this means this will get overridden by 2, here it will be 3, here it will be 4, here it will be 5, here it will be 1. This is how we perform the left rotation. Everybody understood this approach?
Yes, sir.
Okay, now let us see how to code this approach. Okay, I'll come to the coding window, you see that. So here, see this, I'll just zoom it in a bit. So now I have created a function sol. So it takes array as an input and it takes number of elements as an input. Okay, now that's what we do. In the temporary variable, we are storing the initial element. That's what we did in the previous. So if we had this 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5, this was our array. So in the temp variable, so temp variable get created. So there we'll store array of 0. Array of 0 is this. This is 0, 1, 2, 3, and 4. Array of 0 is 1. So we'll store this into this. So after that, we'll run a loop. Okay, we'll run a loop from 0 to n minus 1. Okay, we'll run a loop from here to here, so that we'll shift the elements. So what is this loop basically doing? It is shifting the elements. If you see it over here, it is assigning array of I plus 1. The previous element is replaced by the next element. That's what it is doing. So this will be replaced by 2, this will be replaced by 3, this will be replaced by 4, this will be replaced by 5. Okay, so after this loop is done, so now what we are doing is we are saying array of n minus 1 is equal temp. So we are giving this temporary variable over here. So this will be overwritten by 1. Okay, after that I am printing the array over here. So if I run this code, we'll see that I am giving 1, 2, 3, 4, 5. So this will be 2, 3, 4, 5, 1. So if I am giving, like, let's suppose 6 again. So here you can see this. So I have to give elements is 6. So here's the answer. 2, 3, 4, 5, 6, 1. Is this question clear? Can we move to next question?
Yes, sir.
Now we'll just have an extension of this question. So we'll have an extension of this question. So the question is like this. Again, now you are given an array. So you are given an array of integers. So here if you see it, you are given an array of integers. Rotate the array by k elements now. So we were rotating by one element. Now we'll rotate it by k elements. You can rotate it by left or right. So it depends on you. So that's why I said left rotation or right rotation. Okay. So now we'll rotate it by left, let's suppose. Because we are doing the rotation by left, we'll rotate it by left. So this means, let's suppose if we have this as an input. So this is our input. Our input is 1, 2, 3, 4, 5, 6, 7. If k is equal to 2, so we'll rotate it 2 times. Okay, the same thing we'll do, but we'll do it 2 times. I hope the question is clear. If there is an array 1, 2, 3, 4, 5, so like this, we have an array in which we have elements 1, 2, 3, 4, and 5. Now the question is that if we want to rotate this array twice, so rotate this array twice. If it is a left rotation, so what will happen? This element will go at the end. This element will also go at the end. So the answer will be 3, 4, 5. So first it will be 1. It will be 1, 2 like this. 3, 4, 5, 1, 2. So this will be a rotation, left rotation by 2. So here we are rotating 2 elements. So we are rotating this array 2 times. You can have let's suppose k rotations. Okay, is it clear? Is the question clear? Again, take an example. If our
Yes, sir.
array is, let's suppose 3, 7, 8, 9, 10, 11. So let's suppose we'll rotate it 3 times. So what will happen 3 times? So it will be like something like this: 9, 10, 11, 3, 7, 8. Because first this 3 will get rotated, it will go there here. So then the 7 will go here. Then this 8 will go here. These are 3 rotations, and 9, 10, 11 will come at the front. So this will be the output. So this is the question. Think about it and tell me the approach. Approach 1 said by Rian is that we'll call the function n number of times. Because in the previous question we made a function, so in that it was rotating it by one element. Now we have to rotate n times, so we'll call the function n times. But let's analyze this approach. I won't say this is wrong approach, it's a good approach. Now the first thing is, if you see it in here, so each time we'll have to store something in the variable. So how many variables will it require? So what do you think? So how many variables will we require? We have to save a variable somewhere, because you are
सर
calling
दो
it
ही
n times. So
वेरिएबल
n,
होगा, एक एक एरे होगा और एक मतलब वो क्या कहते हैं, एक इंटीजर वैल्यू होगा, सेम नंबर ऑफ वेरिएबल्स रहेगा.
you can do it again and again. Okay, so अभी पहले time complexity. Let's see time complexity first. So how much time will it take? What do you think? How much time will it take? Analyze the time, because you are calling that function. You have that function which is storing something and shifting the elements. So that function call will take order n time, and you are calling this function n times. So how many time have how many what's the time that will take? It will take order n square time. Do you see why would it take order n square time? Because you will call the function n times, call the function n number of times, and within the function, each the function call itself takes order n time, because it shifts the element, so it will take order n square time. So how many of you are able to see it? Then if you see space complexity is, we only take one variable, that's order 1 space complexity. Rian, Zubair, everybody is are you able to understand this?
Yes, sir.
So how many of you are convinced that it will take order n square time? I cannot see the screen, you have to speak.
Yes, sir. Yes, sir.
Okay, this approach will work, but it will take order n square time. So can you just modify your approach somehow so that it takes less time? Can you do it? I think Asrar said the second approach. Can we use an array of numbers? So what was the approach? Are you able to think something? Unmute everybody, unmute your mic, unmute your microphone so that you speak everything, because I
सर
am
एक
not recording.
सॉल्यूशन सर एक सॉल्यूशन लाइक इस टाइप का मैंने पढ़ा था कि पूरा जो एरे है उसको रिवर्स कर देना है, फिर जितना एलिमेंट है उतना एलिमेंट छोड़ करके मतलब जो एरे दो पार्ट में होगा ना उसको फिर दोबारा से रिवर्स कर देना है इस
Hmm.
करके।
I think yes, that is an approach. But please and please try not to read the approach so that you also brainstorm, and those neural pathways will be in your head so that you next time when you are solving a question you have not memorized an answer. So what Aryan said is, let's suppose we have this 1 2 3 4 5 6 7. Let's suppose we have an array like this. This is our array. So if this is our array, so in here, if we are given some k, let's suppose k is equal to 3. Okay, if k is equal to 3, now what we'll do, we'll reverse the array. We'll reverse the whole array first. Let's suppose we'll by reversing I mean I'll create let's suppose 7 6 5 4 3 2 1. We'll reverse the array. Okay, then we'll reverse the part. So if you see the output of this, so first we'll see the output. If you see the output, so what is the output that we require is 4 5 6 7 4 5 6 7. Then this 1 will go over here, 1 2 3. Okay, so what we'll do is we'll use the reverse way. So we have to get this 4 5 6 7 1 2 3. So from here, so till this part we'll again reverse this array. So first we reverse the array. The first operation was reverse the whole array. Reverse whole array. So we reverse the whole array, we got this. Now we reverse this part of array. So what we'll get? We'll get 4, 5, 6 and 7. And after that we'll reverse this part. This is 1, 2 and 3. Now we got the output that we expected. So now we used reverse operation 3 times. First it took order of n time for all the elements to get reversed. I think it won't even take order n, it'll take order n by 2 because we'll swap the operations. We'll see. So how to reverse now? The question is how to reverse. Let's also compute the algorithm for reverse. Let's suppose we have an array like this 1, 2, 3, 4, 5. So if you want to reverse the elements, so tell me an approach. I think I'll start with Asra. Asra, tell me an approach how to reverse an array.
We can take a new array and just take a pointer to the end of the original array and copy the elements.
Again, the problem is space complexity. You are again taking one more array. Do the reversal in the same array.
Sure. Um, then we
सर
can take a variable, a temporary variable, and just use the swap operation for the first. Use a two pointer approach. पहले एक
Right.
को
Nice. So here we'll keep two variables. We'll swap these. So this will be swapped by 5. This will be 1. Again, increment these pointers. Okay, increment this, decrement this pointer, increment this pointer. Again, swap. This will be 4. This will be 2. Now the pointers reached here, so you won't swap. So you're swapping till you get the same element, till your pointers point to the same element, or maybe they exceed each other. So in terms of the number of elements are even. So now you see that this is reversed 5 4 3 2 1. So how much time will the reverse operation take? I think order n time. Order n by 2 is order n time. Okay. So this is what we're analyzing this. So here we are using an array. So the algorithm goes like this. The first operation is you reverse the whole array. Reverse whole array. Then the other thing is you reverse array till k, till the kth element. And the last operation is reverse the array from kth k plus 1 to end. This is 0 to kth. This is the algorithm that we saw here. Now the reverse operation for this takes order n time. So again here it will take order k time, and this will be order n minus k, something like this. So if you see overall, it will take order n time, overall complexity, because we don't care about the constant. If it is order 1.5 and 1 2 n, so we'll still take order n. So what is the time complexity? So this is our time complexity now. So what is the space complexity? Because we are not using any additional space, so space complexity is order 1. Okay, now let's see the solution. We'll code the solution and we'll see it. So if you see it over here, I have created a function reverse. This is my function. This is reversing the whole array that I'm giving. So it is taking array it is taking I and j. This means what part of array do you want to reverse? Okay, so let's see this reverse algorithm, how it works. If it is 1, 2, 3, 4, and 5, so what will this do? So if I am saying a reverse from here to here, so this will be my I and this will be my j. This is what I'll be giving. This is my I and j. So now if I'm what I'm saying is while I is less than equal to j, so I'm saying this I till it is less than equal to j, keep on doing this. Keep on. This is basically swap. This is the shortcut of swap in Python. Many of you are might be seeing it for the first time, because this is how we can swap in Python. So you'll just create array of I, and you will write array of I, array of j is equal to array of j, array of I. This is swap operation in Python. Okay, this is called as syntactic sugar. So internally it will be using a swap operation, but this is how we'll write as a programmer. Okay, that's why I said the philosophy of the Python is ease of programming. So that's what it provides. But if you have to swap in other language, you'll have to create temporary variable. There are other methods to swap also. So now what we are doing is we are swapping, and then we are incrementing I and decrementing j. So the thing that we just saw in the theory. So now what will happen is this will replaced by 5 and this will be replaced by 1. So these pointers will get incremented. This will get incremented and this will get decremented. Again, this will be 4, this will be 2. Now the pointers are pointing to this. Now this loop will break, because I is now, while I is less than equal to j, so we'll keep on doing this. So once it exceeds this, I is less well, it will exceed this, so this will become here. So what will happen that time is, so now I is here, j I is here, and j is here. So this loop will, this will break, and it will now return the array. It will return the reversed array, the array we had. And after that, now we'll rotate. If you see it over here, there is one important thing that you have to look over here, because sometimes I can tell you to rotate array 10 times, but the number of elements in array will be 5. Let's suppose 1, 2, 3, 4, 5 is the array, and I am telling you to rotate it 10 times. It is perfectly legit. So what I'll do is, in the first rotation 1 will go here, in the second rotation 2 will go here, in the third rotation 3 will go here, something like this. I'm writing it outside array. So in the fourth 4 here will get 5. Then again, if I am saying rotate it 6 times, that means again 1 will come here. That is where this operation comes in. K is equal k modulus length of this. Okay, and please focus on this operation over here. So why am I doing this? Why am I using this k is equal k modulus length of nums? So if I am told to rotate the array 10 times, and the length of the array itself is only 5, so that means you only have to rotate it, let's suppose 0 times. If it's 5, 10 modulus 5 is 0. Modulus means reminder. How many of you are able to understand this point? Why am I checking this? Why am I keeping
Yes,
k
sir.
is equal k modulus length of nums, like a whole size of array, and I am taking a modulus of this? Are you able to understand this?
Yes, sir.
Then I'm again checking this. I'm again checking if length of nums is greater than. Why am I doing this? Can somebody tell me why am I doing this? This check also. Anyone? So I'm
Sir,
checking this. Yes, yes, yes.
sir, it's actually checking reminder like is there uh, some alphabet remaining?
No, if you see it over here, so this condition is making sure that the element, the array has greater than 2 elements. Let's suppose we have only one element, one in the array. So if somebody says me rotate it 100 times, it is nothing. The one will still remain the same. If it rotate 1000 times, then we don't have to even perform the rotate. We can directly return this array. So that's what I'm saying. If length of nums is greater than 1, then only do the rotation. Otherwise, for the elements which are in the array, for the array which has only one element, the rotation basically is the same array. That's why I'm not doing anything. So if this is a condition, then I am doing the reverse. Reverse the whole array first. That's what I'm saying. Reverse nums 0 comma length reverse the whole. This is the whole array. Reverse the array till k minus 1. Reverse the array from k to element k to end of the array. So this is the 3 reverse operations that we are using. Is the code clear? So
Yes,
let's
sir.
run it. So if I run this code, so you can see your example is 1, 2, 3, 4, 5, 6, 7. So we're rotating by 3. So these 3 will be at the end now. So if you just execute this cell, so you see the output. So 5, 6, 7, 1, 2, 3, 4. Again, if I just rotate it by, let's suppose 100 times. So if I run this, so you will see 6, 7, 1, 2, 3, 4, 5. Because 100 is, it will take modulus. So what is the length of the array? 7. It will take 100 modulus 7. So these many times it will rotate it. Okay, it's like clock because this rotation is cyclic. So when you rotate after let's suppose 7 rotations, it'll be back here. 7 rotations will get the original array. After again 14 iterations, it will get the, let's suppose we'll take 7 rotations. So if you run this, so you'll get the same array back. 1, 2, 3, 4, 5, 6, 7. If you see it over here, are you seeing the output? So here it is. So just keep your focus on here. So I'm saying I am rotating it by 7. Let's again rotate it by 14. So you'll get the same array back. So you're seeing it over here. This is again 1, 2, 3, 4, 5, 6. But if I rotate it by 15 times, this is equivalent to rotation by 1. This is just one rotation. You saw that we got 7 over here. Okay, is it clear? Is this question clear? Now we I think saw 3 approach to this, but the optimal approach, which was taking order n time, and time complexity was order n and order 1 space. This was time complexity, and this was our space complexity. Now moving on to the next question. This is my next question. You have to remove duplicates in place. So what is let me first talk about what is the meaning of in place and out of the place. So in place, let's talk about in place first. Let's suppose you have an array like this: 1, 2, 3, 4, 5, 6. So in place means if you are making change to the same array. Okay, so let's suppose I'll shift this 6 element over here, and I'll shift this 4 element over here. So now I am making the change in the same array. These are called as in place operations. Any operation, if you perform within the same array, you don't use any additional array and then copy paste elements here and there, but you are doing every change in the same array. We call such operations the in place operations. Okay, I hope that this in place operations are clear. Now we'll see the question again. Now the question says that given an integer array which is sorted, this array is sorted, and this is sorted in non-decreasing order. Remove the duplicate elements in place. And what's the goal at the end? So the each unique element appears only once. Only once it should appear. A relative order of the elements should be kept the same. Okay. Let's suppose if there are k elements, after removing the duplicates, the first k elements of the array should hold the final result. It doesn't matter what leaves beyond k elements. We won't care about that. Let's suppose we have this array 1, 1, 2. So we'll remove this one and we'll shift this 2. Let's suppose over here. So the answer will be 1, 2, and we don't care about what are the remaining elements in the array. So in the other example, if you see it here, so this is 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. So what we'll do is we'll keep 0, 1, 2, 3, 4, and the other places we don't care what is there. Okay, it can be empty. You can remove the elements. You can keep the elements. But I just want the first distinct LK elements. So whatever LK element, K distinct elements are there, they should appear at the first part of the array. I hope that you understood the question. Please try to solve it and tell me the approach. Okay,
आप एक
so
array ले लीजिए सर.
let's suppose this will call as approach 1. Whatever it's the spelling is. So let's suppose we have an array like this. This is our array 1, 1, 2, 2, 3, 4, and 5. Let's suppose this is our array. So tell me your approach now.
एक pointer 1 को पहले element को point करेगा और दूसरा the second one.
Okay.
If they are same, the first one will get replaced by the second one.
So we'll replace this element, is it? We'll replace this element over here.
Yes sir. और दूसरा फिर shift करेंगे.
Let's suppose we're shifting this. Okay. Then
इस pointer को भी आगे लेंगे ना सर जो पहले में लिया था.
okay. Think me as a compiler. I'll act your compiler. Whatever you tell me, I'll do that. So you told me to initialize the first 2 pointers. I initialized them. Okay. Then you told me to shift this. I shifted it. So what else? So I'll just increment the pointers if they are same. Is it?
एक मिनट से यहाँ पे.
Yes. Think. Hey, you're going in the right direction though. This is the good direction. But think. This is what will give you logical thinking. People many times ask me, sir, how to build logical thinking. So this is how you can build logical thinking. Do not look at the answers. Apply your own brain and try to come up with the answers. If they are wrong answers, you'll adapt and then you will improvise on your answers and you will see, okay, this was the wrong approach I was thinking.
जो आपने पहले को point किया था.
So you are saying you will not update the first point.
I
is
will
it?
not update this pointer. Yes sir.
Okay. So what will you do then?
because I found the same elements. That's why I have updated the second pointer. Now
Okay.
I will copy the element in the second pointer to the last position. इससे
So you
जो
are telling
इस
me
point, yes sir,
this element, where should I copy this?
इसके previous position पे
Here,
-1.
here.
Yes sir.
Okay, so let's suppose I'll paste it over here. Let's suppose I write 2 over here. Now you will increment this pointer, is it?
Yes sir.
Okay, and this pointer is gone though. Okay, now 2 is again there. So how will you even compare now 2 is equal to 2? How will you compare even, because you lost the pointer?
Because I have copied the element now, I will update the first pointer also.
You'll update the first pointer also. Okay.
Now again I will compare with these two pointers.
Okay. Now they are same and you will just update this. Is it?
Yes sir.
So now you found different elements. So what we'll do is,
Copying the
if you copy it to the previous, you see the problem.
yes sir, yes sir.
Again adapt. Now this is again you're going in the right direction. This is how you should think. Okay, let's again write this. So it was 1 1 2 2 3 4. These are 2 pointers. Okay, now think again. So what should we do? If you found the same element, so you are updating the pointers. You're updating one pointer at least.
सर एक अप्रोच हम लोग यूज कर सकते हैं कि भाई टू पॉइंटर अप्रोच था ना कि जब तक सेम एलिमेंट मिल रहा है
Mm-hmm.
तब तक उसको इग्नोर करते जाएंगे, लेकिन जैसे डिफरेंट एलिमेंट मिला तो पहले पॉइंटर को हम लोग अपडेट करेंगे और डिफरेंट एलिमेंट को वहां पे मतलब पुट कर
Right.
देंगे.
This is what I think is the approach. So till we have the same elements, so what Rian said is we have these 2 pointers. Till there are same elements, keep it as they are. So for example, let's suppose we have same element. So we'll not do anything. So since we are like, we'll keep on updating the other pointer. So once we have different elements, we'll try to paste the value. Let's suppose I'll start this. I'll start writing the code. So what I have, I'll start this I from here. So this is my first pointer. And I'll start my j from here. Okay, these are my 2 pointers. Let's suppose I is equal to 0 and j is equal to 1. This is how I'll start it. Then I'll say if the elements are not equal. So if the elements are not equal, then increment I and paste the element j in the element ith position. Okay, this is what I'll do. So if you see it over here, these elements are same. Okay, now I'll increment j. So j will become 2. So I'll increment j. It'll be 2 right here. So now if you see, these two things are now different. Okay, if they are different, so I'll increment the ith pointer over here and I'll swap these now. I'll swap the I'm not going to swap, I'll just paste this 2 over here. Okay, this is my approach. So that there are two things happening. So when is j incrementing? J is incrementing if in the both the cases, j is incrementing in both cases if the element is equal or not equal. But when is I incrementing? I is increment only if the elements are not equal. So now j is here at 3. So j will be here. Now again it found the same elements. Okay, it will go here. Now it found the different elements. So now I will point here and we'll just replace this element 3 over here. Okay, and j will now point to this. Again now they are dissimilar. So I'll increment over here. So now I'll paste this 4 over here. Okay. Now this element will again, this j will again get increment. Now these are again dissimilar. They are again not similar. So this will increment it over here. So this 5 will get replaced over here. Okay. And now we see that these are k elements and we'll keep on doing this. So because I think, and this is the approach, I think this will work for everything. Let's do the complexity analysis first, and I think this is the correct approach. Yes, I don't see any problem with this approach. And because we only want these many elements, so the distinct number of elements, and we don't care about other elements. Whatever there are, I don't care about these elements now. So let's suppose we'll do the complexity analysis, time complexity analysis. So how much time does it take? I think it takes order 1 because we iterate through whole the array. So it takes order and time. So we do not go back and forth. Okay. So what is the time space complexity? I think space complexity is order 1. Okay. This is the algorithm. So let's see it in the code and we'll just analyze it there. Okay. Now if you see it over here, so we're getting array as an input, nums array, and I'm starting a pointer I is equal to 0, and then I'm starting j from 1. Okay. So again there are two things. If you see, when does I get increment? I increments if elements are different. If elements are different, and j gets incremented. So this gets incremented here. This gets incremented every time in every loop, or every iteration it gets. Every iteration it gets incremented. Now we have this 1 1 2 2 3 4 3 4 4 5. So what are we doing is, so here if you see, if the element is not equal, then we are incrementing the pointer I and replacing the nums of jth element with the replacing ith element with the jth element. Okay, and then this result I plus 1 says how many distinct elements. This is I plus 1 basically means these number of distinct elements I got. Okay, that's what at the end I am returning this nums of till the result. So this is the Pythonic way of saying only consider the array till ith position. Okay, so this is why I'm getting this output, because I don't care about what the other elements. So if you just give an output 1 1 2 2 3 4 4 5, so now you know the distinct elements are counted by this I1. So this is what keeps the track of number of distinct elements. So I'm giving this result as I plus 1, so I only want the array till the ith point. So that's what I'll give it. If I run this code, so again I'll run this code. I'm giving this input 1 1 2 2 3 4 4 5. So if I run this, you will see I get the output 1 2 3 4 5. Let's suppose I'll have this 5 5 comma 6 6. Now if you again run it, so now you see that we get 1 2 3 4 5 6. Okay, I hope that this is also clear. Now we'll move on to the next question. So next question is finding the missing element in the array. Okay, so from here we'll build different concepts. So each of the questions I chose so that you build different concepts. Like we just build two pointer approach, there will be a lot of questions which are based on this pattern of two pointers. And now from here you will see another approach. So the first thing that here we have, will be given an array. So if you see it over here, so we'll be given an array like this: 1 2 3 5. So now you see that 4 is missing from the array. Okay, now you will have to output 4 from this array. So again, if you see this 1 2 3 4 5 6 7 8 9 is missing from the array, so you'll have to give 9 as an input, and it can be unsorted. It's not necessary that it will be sorted. Sometimes you can be given 2 3 2 3 1 4 6, something like this. This is your array. So now you know that 5 is missing. Okay, you'll have to output 5. You'll have to find the missing element of the array. That's the question. Tell me the approach now.
Of array.
Okay, you'll check the size. Let's suppose I'm your compiler and I have the element 5 4 3 1 6 and then 8. 7
Yes,
is
sir.
missing, huh? 1 and 7 is not missing. I'll write 2 also somewhere. So 7 is missing now. 1 2 3 4 5 6 7 is missing. Okay,
And then we'll check the
let's suppose length of this is, you are saying that we'll first keep the size. So size is 1 2 3 4 5 6 7 elements are there. This is 1 2 3 4 5 6 7 elements. So I think like in this in the array of 7 we should actually have the size of 8, because one element is missing. So in total we should have 8 elements, but there are only 7 given to us.
yes, sir.
Okay, after that what will you do?
So after that, we will check the maximum value.
Okay,
Like,
let's suppose maximum is 8.
yes, sir.
The size is 7 actually here, but I wrote 8 because in actuality I need 8 elements. So size is 7, maximum is 8. Okay,
Then we will iterate through all the values,
okay.
uh, and we'll check which one is the like. If 7 is missing, so we'll check accordingly.
How can we check that? That's the question. How to check the 7 is missing? Oh, I see. What you are saying is you will compare basically. What you will do is,
Yes, sir.
if I understand you correctly, you are saying see the maximum element is 8. So you'll run the loop from I is equal to 1 to 8. Okay, and then you will see if 1 is present there. Okay, if 1 is there, so it is there. If 2 is there, it is. So you will. So what is the time? Maybe this is an approach. I think this is a correct approach also. So if you see time complexity, this will be order n square. Why? Let's suppose for this loop. So you will check all the elements if 1 is there. So you have to go to all element. So in the first iteration it will run n times. Then for the 2 it will again run n times. For the 3 it will again run n times. For the 8 it will again run n times. So do you agree that it will run order n square times?
Yes, sir.
Okay, can we do better than this? I think this is a good approach. This is an approach going in a right direction. This is brute force. We call these approaches brute force. Brute force means checking all possibilities. So we are running our loop from 1 to 8, because 8 is the maximum element that we have. Or we can say, when you said the size of array was 7, so we'll go till 8, because we are expecting to have 8 elements in there. So now what the approach said is check with 1. So 1 is there. Okay, check with 2. Check every element. 2 is there. 3 is there. 4 is there. 5 is there. 6 is there. 7 is not there, then return 7. But in the worst case, it will take
सर
all
आई
the
हैव
bits.
वन अप्रोच।
Yes, yes.
सर हम लोग क्या करेंगे कि पूरे एरे का ना हम लोग सम ले लेंगे,
Okay, nice.
और उसका जो मैक्सिमम एलिमेंट है
You take
उसका
the sum of
मतलब
array. Okay,
एन
wait.
एन टू।
You'll take sum of array.
हाँ
So, okay, sum of array means you will take order n time. So this will be 5 plus 4 plus 3 plus 2 plus 5 plus 4, and then yeah, you'll have some sum. Let's call it s. Okay, and after that,
और उसका जो मैक्सिमम नंबर है फॉर एग्जांपल 8 है, तो 1 टू n तक का जो सम होता है, जैसे मतलब n इंटू n माइनस 1/2 वो होता है ना।
okay, so you'll use the arithmetic progression sum. Okay.
हाँ, और इन दोनों को सब्ट्रैक्ट कर देंगे, नंबर निकल जाए।
That's also, you'll find sum of the array. You'll find uh, sum of n natural numbers, n natural or n natural numbers. I'll say that is, you'll sum it from let's suppose from 1 to, here we have 7 elements. You will sum it till 8 elements. So you will sum 1 2 3 4 5 6 7 and 8. Okay, then this is n into n plus 1/2, I guess. So this is n is 8 over here, into 4 divided by 2. So this is 16. Is it? No, no, 8 for
यस सर।
32. 32 divided by, just check the calculation once. So this is 9, I think. 8 9. So this is 436. This is 2 ones are 2 2 4 4 9 36. So this is 1 2 3 and 4. So how did I even compute this? I don't even remember the formulas. You know how I compute this? I'll tell you that thing. So if you see this element and this, they'll sum up to 9. If you element this and this will sum up to 9. This will sum up to 9. This will sum up to 9. This will also sum up to 9. This will also sum up to 9. So there will be half number of 9 elements. So that's why I said first element plus last element. That is 8 plus 1. So this will be 9. And then in total, how many pairs of numbers I'll have? So I'll have 8 by 2. 8 by 2 such pair. That's why the formula is n into n plus 1/2. How many of you understood this?
Yes, sir.
That's why you should not memorize the formulas, because anytime you can go wrong. That's what I did. I said the first element plus the last element. This is the second element and the second last. They all sum up to 9. That's what I said. N plus 1. Last element plus the first element. And then such pair, how many pairs will be such? Such will be 8 by 2. 4 pairs will be such. So I think 36 is the answer. So the approach Rian said is that 36, then minus the total number of elements, the sum of the array. So S, this will give us 7. I think this is also the correct approach. So how much time will it take? It will again take order, I think 2n time. So because not even 2n, I think it will take order n. This is a good approach, because you just have to perform computations. So this, if you know the length of array, you will take n into n plus 1/2. So this will take constant time, and then you have to just iterate through this array once so as to get the sum of the array. And this is a good approach. Yes. Can you think of any other approach? There are other approach also. Let me tell you one more approach, because I don't think you guys will be able to get that approach, because it's a little bit not even complex, I'll say, because you are not trained to think in those lines. So first, let's explain about XOR operation. So how does XOR operation work? So how does XOR operation work is, let's suppose I have two bits. I have bit A and I have bit B. So exclusive OR says that if the two bits are dissimilar, then the output will be 1. For example, if it is 0 0, it will be 0. If it's 1 1, it will be 0. But if they are dissimilar, like 0 1 and 1 0, for two bits I'm saying, so this will be 1 1. So this is XOR is also called as modulo 2 gate. So what is the meaning of that? It means, let's suppose I have now 3 bits A B C. Okay, if it is 1 0 and 1. So how to now compute what will be the output? You take the sum of these bits, okay, then take modulus by 2. The sum of these is 1 plus 1 is 2, okay, and 2 modulus 2 is 0. So this is 0. If it is 1 1 1, now we have odd number 3. 1 plus 1 plus 1 is 3. 3 modulo 2 is 1, so you'll get 1 over here. So even now, if you have any n bits, so give me n bits. So what you will do is you will add all these bits and then take the modulo by 2 and you will get the XOR operation. Is the XOR operation clear? So if I have A,
Yes.
B, C, D input now, so I am giving you 1, 0, 1, 1. So what should be the output? Asrar, what should be the output? So what should be the output of XOR gate?
1, sir, 1.
So 1. So if I have 1, 1, 1, 1, so what should be the output?
0.
0. So this is how XOR operation works. So I hope that you now understood how XOR works. So now, why am I telling you this? So let's suppose we have same number. We have a number, let's suppose we have number like this. 1, let's suppose we'll take number 8. So 8 will be represented by 1, 0, 0 in the binary. So if I XOR with 8, if I XOR this number with 8, so what will happen is, I'll get 0. Okay, you see 0, 0 is 0, 0, 0 is 0 because I told you that this is a modulo 2 gate. Okay, if I XOR the same number, if I XOR two number which are same, I'll XOR, let's suppose 7 and 7. So 7 and 7 will be 1, 1, 1, XOR 1, 1, 1. So it will be 0. So now I'll use this XOR operation to do this. So I have 1, 2, 3, 4, 5, 7. Let's suppose 6 is missing. Okay, so what I'll do is, now I have 7 numbers. So I'll XOR with 1 XOR, I'll XOR with 1, 2, 3, 4, 5, 6 and 7. I'll XOR with everything. So this 1 will cancel out this 2 will cancel out this 3 will cancel out this, 4 will cancel out this, 5 will cancel out this, 7 will cancel out this. Only XOR of 6 will remain. Why? If all gets neutralized, so we'll be left with 0, 0, 0. Then XOR 6. So XOR 6 is 1, 1, 0. So we'll be left with only 6. So if you XOR any number with 0, so it is that number. So that's how I'll get this number. So what I'm telling you is XOR. So if you have here the length of array is, let's suppose 6. Now you XOR with 1, 2, 3, 4, 5, 6, 7 elements. So the elements that is not there, the element that is not in the array, that will be the only element which will be left. Others, the other elements, they'll be neutralized or they'll be cancelled out by XOR. How many of you understood this approach?
Yes, sir, got it.
Or is there a confusion? Is there a question? Have everybody understood this? Let's go to the code and we'll see. I think I have written code for this also. I think I have written, but I don't know exactly. Luckily I have written. So here if you see what I did is, so I have kept XOR of 0, XOR of 1 is, I started with 0, XOR of 2 is also with 0. So then I iterate through whole of the array. Okay, and then I am doing XOR of 2, I am performing XOR with A of I. Okay, this is the first I am doing XOR with 0. Then I am saying XOR of 1 is equal XOR of I plus 1. So this is my number now. Okay, this is my number because I, if you see it over here, I starts with this. So this is basically performing the other operation. At the end, I'll just XOR these because I don't want to miss the things. The approach that I described is the same approach, but here I just need to keep a track of different things so that I don't miss the things. That's why I just initialize these two variables. Okay. Now if you see this, so if I have n is equal 5 and then I have 1, 2, 3, 4, 5, here 3 is missing. So if I run this code, so you'll see that it is showing the 3 is missing over here. If I run, let's suppose 1, 2, 3, 4, I'll also write 3 over here. Now the 6 is missing, so I'll write the 6 elements. So if I run it now, you say that it shows 6 is missing. This is the approach. Okay, I think that you got the approach, but just keep the track. Why am I having this x or 1 and x or 2? So this is just because I need to at the end I need to collect the result of these two things. Okay, and this loop is basically giving me all natural numbers and then I'm XORing with these numbers. I hope that you got the approach. Now let's move to the next question.
सर बट इसका टाइम कॉम्प्लेक्सिटी भी तो ON लग रहा है.
Yes. I'm saying it also takes ON. This is the same approach, but I just wanted you to know there are other approaches. So I wanted you to learn how you can use bitwise operations, bitwise XOR operation. It is not the better approach. It doesn't, because order n you will have to anyway go through the whole array. But I think here you learned that XOR can be used somewhere. So now the next question is that there is an array given to you, okay, and one number is there which appears only once. Other number they appear twice. So if you see in array, let's suppose you have an array like this. So over here you see an array. So this array is 2, 2 and 1. So now you see that this 2 has appeared twice. The only 1 is appearing once. So you will give output as 1. So now if you an array like this 4 1 2 1 2, so you see that 2 is appearing twice, this 1 is appearing twice, but the 4 is appearing only once. So you have to output the element that is appearing once in the array. All the other elements are appearing twice. So how can you do this?
सर अगेन यही आपका अप्रोच बिटवाइज XOR करेंगे. The
Right.
elements which we are left with, they have only appeared once, and the
Yes, yes,
elements
yes.
which have vanished, they have appeared twice.
Yes, yes, yes. That's why I showed you XOR. Because the XOR operation, it cancels out the things. So if you did not know about XOR, so maybe you will think about some other ways. You'll think, okay, I'll keep a track whichever element is there. But here, if you do you see how XOR simplified the operation? How XOR simplified this question? So
Yes,
because
sir. Otherwise, I would have thought of like first sort the array and then keep a track of the elements, go with the for loop. That would have been tedious. This one is quite simple.
सर आवाज नहीं आ रही.
so I'm telling you, like these bitwise operations are quite powerful. So if you learn about the bitwise operations, they are quite powerful. So let me again show you some application of bitwise operations, like which I can think of. Let's suppose you have to check if a number is even. Check if a number is even. Okay, normally how would you check if a number is even? So what you take modulus operation of 2. Let's suppose you take modulus with 2 and you see if it equal to 0, then it's even. Let's suppose we have a number, you check if it is divided by 0, and if the modulus is equal to 0, then it's even, otherwise it's odd. This is a normal approach people use. Okay, and if you see it from a from a perspective of a compiler design, so what it does is it uses an arithmetic circuit. So what it first does is it uses the division operation. It divides this number many times. So after that, it will see if it divides perfectly, it will give 0, otherwise it will give 1. So then it will have to also compare the numbers. It will have to compare if it's equal to 0. It takes a lot of operations if you see from the perspective of a compiler design or from a computer architecture's perspective. So you see that it takes a lot of operations. Now if you know bitwise operations, so what you can do is, so if you have any number, you'll perform bitwise AND. So you'll perform bitwise AND with 1. So what you'll do is you'll perform bitwise AND with number 1. So if this number is odd, so this will give output 0. So this will give output 1 if the number is odd. Otherwise, this will give number output as 0. Let's see why. So let's suppose you are checking the number 3. So in 3, binary is 1 1. So now if you AND it with 1, so 1 means 0 1. So you'll get the output 1. So for the odd numbers, it will always give output 1. So now if you take an even number 8 1 0 0, if you perform AND operation with 1, so this you will be this and this you will get 0 as answer. Okay, for the even numbers, if you perform an AND with 1, so you will get 0. For the odd, you will get 1 as an output. So now if you have to check for even and odd, you don't have to just take the modulus of 2. It is better to do number and perform the AND operation with 1. Okay, and then let's suppose you will say if it is equal to 1, so what will happen? You will just say it is odd, otherwise it's even. So here you are saving the operation because you are just applying the AND operation. You are not performing a lot of divisions and then you are finding it. You are like saving your space, and even you don't have to even compare. So even if you write if number and 1, this is odd. Okay, this AND means true basically. If this is the number 1 means true, 0 means false. So if it is this is this automatically gives true, and this is odd, and otherwise it's even. How many of you understood this operation?
Yes, sir.
Okay. Let me again show you that the things that are coming to my mind. There are a lot of bitwise applications, but whatever comes to my mind right now, I'll tell you that. Let's suppose I have a number. I have a number 8. Okay, 8 is represented like 100. Let's suppose I want to double this number. Okay, if I want to double that, suppose this number is stored in age equal to 8. Okay, so what I'll do is I'll say a multiplied by 2 and store it there. So this is equal to 8 multiplied to 16. This is how we'll use a from the compiler design perspective, from the computer architecture perspective, you will use basically a multiplier circuit, and then it will double the element. So if you are multiplying by 2, even if you are dividing by 2, you do the same thing. So but there is a better way. So what is the better way? You can shift this. You can use shift operators. Okay, if you have to multiply it by 2, just left shift it. So you'll just left shift means you'll left shift it once. So this is my register, so you left shift it. So this now becomes 16. Okay, if you have number, let's suppose 13. So 13 is 8 4 1. This is 13. This is 13 in binary. So if you have to multiply it by 2, so you'll again shift it by left. Shifted by left is adding 0. So now if you see this number is multiplied by 2. So if you see the left shift operation, basically if you are register and you shift it, and then you are multiplying by 2. If you right shift it, so this is by division by 2. And the shift operations, they are really easy. So if you see from the computer architecture perspective, again you are just shifting the register. You are not just computing it on the circuit. You are shifting the register, it is performing the multiply and the division. This is again a powerful operation. Sometimes like you must use these operations while coding, because they'll, for example, let's suppose I'm doing 100 operations, even 1000 operations where I'm multiplying by 2. So you are 1000 times you are using the multiplier circuit. So it is better you shift it, because let's suppose if shift operation performs 0.01 nanosecond is better. So it will have a humongous impact if you are performing at 1 million, 2 million points. Okay, and please read about these operators so that you also learn about how I can reduce the complexity on the circuit level, how not to use these adder, multiplier abruptly. Is there a better way? I think bitwise operators are the one operator which are, I'll say, underrated. So these operators are not taught anywhere, but they are so powerful. If you know about these operators, they are so powerful. Maybe we'll have a separate session on bitwise operators someday. Okay, I'll tell you where can bitwise operators be used. Right now I showed you XOR operator. What is the power of XOR operator? Bitwise XOR. Then I showed you what is the power of XOR and XOR operator. I showed you bitwise and. Then we saw what is the power of shift operators. I hope that you got this, and from the next session we'll continue discussion on arrays, and today I'll post some questions on the GitHub.